So the topic that we are going to go today, it's absolute dependent motion analysis. To understand the dependency of one particle on another or dependency of one motion on another, let's consider this example. So absolute dependent motion of one particle on another. So for this understanding, let us consider this example or this diagram. We are having two blocks, that is block A and block B. So both are having different masses, definitely will be having different weights. So both are connected with each other with the help of rope. And let us consider that this rope is inextensible. So definitely the question arises that why we want to study the absolute dependent motion analysis, or why we are doing this type of analysis. So in many problems, the motion of one particle is usually, sometimes it depends on the corresponding motion of another particle. So if we analyze that thing, so we will be able to solve such type of cases in which the object of one body, object of one particle is dependent on some other particle. Okay, so let us consider we are having two masses, two blocks, block A and block B. So both are connected with the help of rope, and the rope is passed over a pulley. Now this pulley, this is basically inextensible, means no extension is possible, no deformation is possible in this. Let's assume this thing. Okay, now if block B moves downward, so as a result of this downward motion, the block A, it will move upward. Similarly, if block B moves upward, or if block A move downward, so this block B will move upward. So means the motion of block A is dependent on motion of block B, or we can say the motion of block B is also dependent on the motion of block A. Okay, so what we need to do basically, we need to analyze those things, and we need to set up a strategy to mathematically solve such type of problems. So what could be the steps for studying or for analyzing such type of motion, or for studying or analyzing absolute dependent motion of particles? Okay, so let's study the step one by one. So the first step that we have, what we need to do, for example, if we are having this system consisting of a rope, pulley, and the two masses are the two particles, and the motion of both these particles are dependent on each other, these two particles. So the first step that we need to do is we need to set up our coordinate system, or we need to set up the origin. And for we need to, if we are having just a single motion, or the motion is passing through a single point, so in that case we can have origin, or in some cases we may need to define some datum. Okay, so in this case, let's have our datum plane over here as shown in this case, and we need to define our coordinates, means the positive distance and the negative distance. So for that purpose, let's say this S is representing the positive displacement. Okay, so the first step is set up a coordinate as along the direction of motion from a fixed point. So this fixed point, it can be origin, or it can be from a fixed datum plane. So in this case, we are having a fixed datum plane. Now the second step is represent the distances, means from this origin, from this datum plane, what we basically need to represent the distance of object A and the distance of object B. Okay, so represent the position of object. So means if we specify the distance, this means the position will be specified automatically. So represent the position of object respectively. So let's say object A is having a distance of SA from this datum, or we can say SA is a position vector that basically represent the position of object A or block A. And this SB, this is basically a position vector, or this is a distance of object B from the datum plane. Now what about step 3? We need to identify constant length. If there is any constant length in this whole system, we need to identify. Okay, so if you look at the green color that we have over here, means this semicircle portion, this distance, it will remain same, it will not change, this length will remain same. If the object A moves upward or it moves downward, Now, if the object B move upward or it move downward, in both cases, whether object A is moving upward or downward or object B is moving upward or downward, this length will remain same. It will remain constant. So that's why we need to recognize those constant lengths. Okay. So in step 4, what we need to do, we need to find out some relationship between the distances, or the relationship between the motion, or relationship between the motion of objects. Okay. So step 4 is basically finding the depending relation between the positive variables. So the positive variable in this case, as we have as positive downward, so S is positive downward, we are having SA and we are having SP. Let's try to find out some relationship between SA and SP. Okay, so we know that in this case, the total length of this cord, or the total length of this rope, it is basically equal to SA plus SB and plus this constant length. So if we combine all of them, so what we will get, we will basically get the total length of this rope or this cord or this object, which is basically connecting these two masses. Okay, so SA plus L semi plus SB, that is equal to the total length of this cord, or another word, it can be termed as the total length of this cable or rope. Now, basically, we are interested in finding the displacement, then velocity, and then acceleration. So we get this relation, which is basically showing the relationship between, we got this equation which is showing the relationship between SA and SB. So let's differentiate it with respect to time. So in step 5, what we need to do, we need to differentiate this equation with respect to time. Okay, so when you differentiate, it will be d by dt on the left side, as well as it will be d by dt on the right side. Okay, so since this one is constant, this one is also constant, so when you take this derivative inside, so derivative of constant and derivative of constant should become 0, and what we will get d sa by dt plus dsb by dt is equal to 0. dsa by dt, this means this is basically velocity of particle A, and this one is basically velocity of particle B. Okay, so when you take vb on the other side, what you will get, va is equal to minus vb. Okay, so the negative sign here, it basically indicates that if block A moves downward, so its velocity will be positive. In that case, block B will move upward and its velocity will be negative, because positive sign is downward. So this equation basically represents this thing. Now we can also write it like VB is equal to minus VA. So what that represent? This represent that if block A moves upward, if this block A moves upward, which is in the negative direction, it will be having negative velocity. So this block B will move downward in that case. So means if block B moves downward, block A will move upward, since downward velocity is positive and upward velocity is negative. So that's why we can have this equation. Okay, so now we got the velocities. Okay, what about other step? If you want to find out the acceleration, so then we can go through step 6. So if necessary, repeat the differentiation and extract the relationship in acceleration. So again, time derivative of left side, time derivative of right side. When you do so, what you will get basically acceleration of particle A and acceleration of particle B. So these are the few steps which we need to follow throughout our course or throughout our lecture for absolute dependent motion. Okay, so now to better understand what we have studied so far, let's consider an example. So for the pulley system, as shown, the velocity of object A is known. Velocity of object A is known, it is upward. And it is how much? It is 3 meters per second. Determine the velocity of object B. So means if it is moving upward, we need to find out whether this object will move upward or downward. So we can identify this thing from general observation by looking at the diagram, but we also need to find out the exact value of velocity at B. Okay, So let's apply all those steps. So the first step is basically setting some datum plane, let it be here. And then the second step will be specifying distances. Okay, let this one be positive s. Then we need to identify the distance of object A, similarly distance of object B. So let's look at it. So the first step is set up a coordinate along the direction of motion from a fixed datum line. Okay, so let this one be the datum and let this be the positive distance or the positive displacement. Okay, now represent the position of object respectively. Okay, now one thing we have to note down here, that in this case we are having two ropes. In this case we are having two rope. One rope is here and one rope is here. Okay, so this is having its own length, this second rope is having its own length. So what we can do in this case, we can define this one length as A, and the length of the different length of second rope as with substitute B. But to find out the relationship between these two, the object A and object B, what we need to have, let's have another distance, or let's have another s with subscript C. Why we are defining this SC? It is just to find out or to just maintain a relationship between SA and SB. So the equation that we will get for object A, it will be between SA and SC, and the equation that we will get for object B, it will be between SB and SC. So SC in this case, it is like acting as an intermediate relationship between these two. So I have mentioned all those things over here. Since the system has two codes with segment that change length, so it will be necessary to use a third coordinate, that is SC, in order to relate SA to SB. Okay, so let the position of object A from the origin or from the datum be SA, the position of object B from datum, let it be SB. Okay, then the position of this point till this point, let it be SC, and it is also mentioned over here the position of this point, which is basically pulley C, from here till the datum, let it also be SC. Okay, so the third step is basically to identify fixed lengths. What we need to do, we need to identify the fixed length. So this length is not changing, one in green, this is not changing, this is also not changing, this one is not changing, again this one is not changing. So what we did, we set up coordinate and then we represent the different position of objects. Okay, then in the third step we identified the constant lengths that is not changing, those lengths which are not changing in the analysis or during the motion or within the given system. Okay, so in step 4, what we need to basically derive the relationship between some dependent relation in which the one motion is dependent on another. So what we can do, let's first consider one row. It can be this one or it can be this row. So first let's consider one of the row from here. It can be this row or it can be this row. Okay, so let's first consider this one, the one shown in the blue. So if we want to find out the total length of this rope, it will be SA, then this SC, and again SC. Okay, and then we have this constant, and we also have this constant, and we have this constant. So let's combine all those constants into one and let it be C1. So what we have, SA, SC, SC in C1, and this is basically the total length. This is basically the total length of rope 1. Now for B, let's have SB and then this one. So this length will be basically, if this is SB, if you subtract If this is SB, if we subtract SC from SB, so what we will get? We will get this line. So SB minus SC plus SB, and again the constant that we have over here, okay, and then the constant that we have over here. Let be combined into C2. So it is equal to the total length of row 2. Okay, so we identified this relation. Okay, now let's rearrange this equation. SA plus SC plus SC plus C1. So when we arrange it, what we will get? We will get this equation. Also arrange this one. When you arrange it, we will get this equation. Okay, so now in this case we need to remove this SC. It is having negative sign over here. So if we multiply this equation with 2 and then add with equation 1, so we can remove this term. So in order to cancel out SC, multiply equation 2 by 2 and then add equation 1 and 2. So when you do so, what we will get? These two, it will be cancelled out and we will get this equation. Okay, so this LT1, LT2, this C2, this C1, all of them are basically constant. So let combine all those on the right side and the other one on the left side. Okay, so we get basically this equation. Let all these constants be equal to a single constant C. So differentiate it with respect to time. When you do so, what you will get? You will get this equation dSA by dt plus 4 dSB by dt. Okay, and that should be equal to 0 because derivation of constant is 0. So we get this equation. Okay, so we are given with VA and we need to find out VB. So take VB on to one side and VA onto other side, we get this equation. Put the value of VA. When you put this value of VA over here, what we get? We get 0.75. So remember, in this case, VA is 3 meter per second upward, and we know that in the coordinate that we set, in that case, upward velocity is negative. So we need to put this VA as minus 3 meter per second. So when you divide that 3 by 4, minus 3 by 4, so what we get? We get basically this thing, that is 0.75 meter per second. And this was what required from the question. Okay, so this is basically the end of question 1 or the end of this example. So what we studied in the previous slide, we have applied it on this example. Now let's consider another example. This example is basically from your R.C. Hibbeler book, and in this what they are asking, determine the speed of A in figure 1239. Again, it is from chapter 12. If B has an upward speed of 6 feet per second. Okay, so we are having this upward speed of B. Okay, so let's, in this case, again, it's up to us. What they did, they identified this datum plane. They have also identified the positions SA, SB, and SC. Okay, so if we fix downward motion as positive, so in that case, VB will be negative. Or if we set upward motion as positive, so in that case, VB will be positive. So this problem is almost the carbon copy of the previous one, which we just explained, or the one that we just did. Okay, so in this case, what we have, let's consider this first row. So again, we need to define, but rather than, they have already defined this SC. Okay, so let's find out the length of this rope 1. So it will be SA, and then this length, which is SC, and again SC, and this should be the constant, this constant, this constant, and this constant. So SA plus SC plus SC plus this constant, it should be equal to the total length of rope 1. Okay, when you arrange it, you will get this thing. Similarly, for rope B, this one, the length should be equal to SB, and again it should be equal to this length. So this length can be obtained by subtracting SC from SB. So this one will be SB minus SC plus SB, and this constant length, this constant as well as this constant length. Let it be combine both the constant length into C2, and this should be equal to the total length L2. Okay, so when you arrange it, you will get this. Again, to cancel out this thing, let's multiply equation B with 2 and then add both of them together. So when you add both of them together, you will get this thing. Let all constant be shifted towards the right side. Okay, and let's combine them to a single constant. Let the single constant be C, so we get this equation. Okay, so to find out the velocity, what we can do, we can differentiate it with respect to time. So since on the right side we are having constant, so it will be having 0 value when we take time derivative. So we get this equation. Okay, so we have VA plus 4VB is equal to 0. Since we are given with VB and we need to find out VA, so VA is equal to minus 4VB. And if this downward velocity is taken as positive, so 6 should be negative. So over here, instead of VB, what we will do, we will put minus 6. So 6 multiplied by 4 will give us 24, and minus multiplied by minus will be plus. So what we get VA is equal to plus 24 feet per second. And over here it is also mentioned that this velocity is basically negative because we are defining downward as positive. Okay, so now let's consider another example to understand that thing fully. Determine the speed of block B. We need to determine the speed of block B in given figure, which is 1240, if the end of chord A is pulled down with the speed of 2 meters per second. So basically what we need to do, we need to find out the velocity of this object B, okay, or in other words this block B, if this object or this pulley or row at point A, if it is pulled downward with a velocity of 2 meters per second. So what we need to do, the first step is basically setting the datum or the origin. So it is already set. Then we need to identify the positive distance or the positive sign, positive coordinate. Let the downward be positive. Then the position. So positions are already mentioned. Okay. And then in third step, we need to identify the constant lengths. So the constant length, again, they are identified in the question. So what we need to do, we need to find out the dependency of both this motion. That's this motion at A and motion at B. Okay. So for that purpose, what we can do, let's try to find out the total length of chord A first, and then the total length of this another chord. Okay. So we are having this diagram. So what we can do, okay. So this length can be identified. That is this one. It can be identified by subtracting SC from SA. So SA minus SC will give us this length. Then we have this constant, and then we have this length again. It is SA minus SC, right? SM, or let's consider this one SB minus SC. Since it's on the right side, so let it be SB minus this one. So it will give us this length. SB minus SC. Okay, again we are having this constant, and then it should be added plus SB, and then we have this constant length. So what we have, SA minus SC, SB minus SC plus SB, and it should be equal to constant, and this constant. So let's combine all of them into a single constant C1. So SA minus SC, SB minus SC plus SB plus C1, it is equal to total length of chord 1. Okay, so when you rearrange it, you will get this thing. Now let's consider the second row, which is this one. So this one, this line, the first one is SC plus this constant line, and then we have this line. We have length from here till this center point. Okay, so this one is basically SC and this one is SB. So SC plus SB, but over here we are having constant plus constant, it should be equal to the total length of chord B. So SC plus SB plus constant C2, it should be equal to the total length of chord B. Okay, so we want to eliminate this SC. So what we can do, we can multiply this equation with 2. Okay, so we can multiply equation 2 with 2 and add it with 1. So when you do so, what you will get, this 2SC, it will be cancelled out with this 2SC, and when you add both of them, you will get this equation. So again, this C1 plus 2C2 LT1 and 2LT2, we will move it toward the right side, and whatever we get, we will combine all those constants into one constant, that is C. Okay, so differentiate this equation with respect to time, so you will get VA plus 4VB is equal to 0. Okay, since we are given with the velocity at point A, which is downward, and downward is positive, so let VA is equal to t meter per second, which is given downward. So put it in this equation. We need to find out VB. So VB should be equal to minus VA divided by 4. So when you put it here, what you will get? You will get minus 0.5 meter per second. Our VB should move upward with a velocity of 0.5 meter per second.